right, I want to start by reviewing some fractions in this very brief review period that we have. The first problem we see on the board is subtraction and addition. Now, if you're watching on YouTube, you have the luxury of pausing the video and working all of these problems and then watching us go over it. Students in the classroom don't have that luxury unless they choose to rewatch the video tonight. We're just going to work them together for sake of time. Whenever we add or subtract fractions, class, we have to have a common denominator. What is the common denominator?
10.
If this were an equation, class, I would multiply everything by 10 to cancel out the denominators, but it's not an equation. Don't cancel away the denominators. Instead, remember, for an addition problem of fractions, we said we're going to draw a big long line, and we're going to put the 10 under it. Then we're going to make these become 10s. How do I make a 5 become 10, class?
Multiply by 2.
Well, what I do to the bottom?
Do the top.
And so the entire numerator gets multiplied by the 2 to get?
6x minus 14.
Make sure you're doing this with me. The next one already is a 10. So I don't have to multiply by anything except
1.
there's a negative right here. What is that going to do?
Put it in the top.
What does a negative do, class?
Change.
It changes signs. Negatives always change signs. So what do I write down?
9 plus 6x.
It already is a 9.
Negative 9 plus 6x.
Negative 9, positive 6x. We change those signs. Remember, there's these parentheses, right? A fraction bar is a grouping symbol. So if we put this in parentheses, we have a negative in front of parentheses. We change those signs. Here, multiply top and bottom by 5. So what do I write above the line?
Plus 25.
Then we just need to do some simplifying here. Adam?
Positive 37x.
When you combine all the x's together, good.
Negative 23.
When I combine the non-x's, all of it over 10. If we could factor and cancel, we would, but we can't, so we're done. Questions on this? Remember adding fractions. Multiplying fractions. We don't need a common denominator. In fact, what we want to try to do is get rid of as much as we can. We want to try to cancel stuff, but lo and ahead offhand, we cannot cancel.
Factors.
We cannot cancel terms, but you can cancel factors. You can only cancel factors, never terms. So here, obviously, then I need to get some factors. Now, 10m cubed already is factors. It's a 10, an m, an m, and an m. The 2m is a 2 and an m. But m squared minus 9, those are two separate terms. I need factors right there, Lana.
M plus 3, m minus 3.
Good, sum and difference, m positive 3, m negative 3. What about the m negative 3? How would I factor these two terms, class?
Nothing.
No.
You don't. I said if you can't factor,
Cancel.
group it.
Yeah.
Remember, technically it's already grouped, but seeing the parentheses will help you. Once we've grouped, factored, whatever, we can start canceling stuff, Dylan.
M minus 3. A 2m out of 10m.
Okay, a 10 and the 2, let's just take it in pieces here to get
5 and 1.
5 and 1. But also this m cancels with one of these m's, but I still have how many left, class?
2.
2 m's. All right, so what's my answer going to be, Adam?
5m squared times m positive 3.
Not times m positive 3, over the m positive 3. I can put parentheses, I don't have to, but I need to specify something. And this m disappeared from the bottom.
M can't equal 0.
M can't equal 0. Also, m minus 3. Cancel it out of the bottom.
M can't equal 3.
M minus 3 can't equal 0, so m cannot equal 3. So we have a couple of excluded values in our answer if you remember doing this. The next one's very similar, except it's a division problem. Wait, Lana, division? Fractions?
Multiply by reciprocal.
Multiply by the reciprocal. So we're going to change this. I'm going to put the 6x cubed up here. And down here, I'm going to put the x squared minus 1, but I'm not going to write it like that. How am I going to write x squared minus 1, class?
Plus 1, x minus 1.
Good, Lana. X plus 1, x minus 1. And that allows me to multiply instead of divide. So we multiply by the reciprocal. I can also do some more factoring here in the first fraction, Dylan.
The bottom you can pull out a 3x.
Okay, bottom I can pull out a 3x.
To get x squared minus 4.
Ooh, careful, I pulled out a 3x. X negative 4. And what about the x squared negative 5x positive 4, Adam?
You could do nothing. You can't do it.
Oh, I can.
Oh, wait.
I can backwards FOIL that.
X negative 4, X negative 1.
There we go. And now, Lana, I can,
Cancel.
what cancels?
X negative 4s and X negative 1s.
And
The 3 and the 6.
to get,
1 and 2. And then the X. And then X squared.
well, X cubed to get X squared. All right, so what do I have here?
2x squared over x plus 1.
The 3 canceled out of the bottom, but do I need to say that 3 can't be 0? No. The X canceled out of the bottom. Do I need to say X can't be 0?
Yes.
Yes, I need to say that. X minus 4 canceled out of the bottom, class.
4.
X can't equal 4. X minus 1 canceled out of the bottom.
X can equal 1.
X can't equal 1. And also, because it flipped, anything that was originally a denominator needs to be set and equal to 0, but I've already said X can't be 0. So I'm covered. There's my answer if you remember doing this back earlier in the semester. Looking at the next one here, Dylan, just a basic multiplication problem. Talk me through this.
Pull out a 5a squared in the top to leave you with a plus 4. The bottom you can, that would follow to a plus 4, a minus 1. That's it.
That's it. What is a squared plus 1, class? Sum of squares. Can we factor a sum of squares?
I mean,
If it doesn't factor, you can't.
Oh.
If it doesn't factor, class,
Oh.
group it. And a sum of squares does not factor. So we don't get to cancel as much this time, Adam.
The A positive 4,
Okay, the a plus 4s do cancel.
the 5a squared and the 10a.
Okay, the 5 and 10 to get
A squared, A.
5 and 10 cancel to get.
A squared.
But I'm not talking about the a's. 5 and 10 cancel to get. 1 and 2. Make your life easy, man. Don't make it hard. Now let's cancel the a's.
A and 0. None.
Okay, so an a in the top, and of course the a's gone. Now what's left in the answer, Adam?
A times A positive, that's wrong. A over.
Well, there's an a left. There's a 1. We don't have to write the 1, but there's also an a squared plus 1 left.
A squared plus 1 over A negative 1. 2A negative 1.
There we go, and then there's a 2 as well. So we'll leave all of this. Now, normally we would specify that a squared plus 1 can't equal 0, but think about it. If you square anything, it's going to be
The same. Well,
positive.
Positive.
And if you add 1 to a positive, it's always going to be positive. Is that ever going to equal 0?
No.
So we don't actually have to say that a squared plus 1 can't equal 0 because it never can. We did lose an a from the bottom. A can't be, excuse me, this isn't a division problem, never mind. But a canceled from the bottom, a can't equal 0. A plus 4 canceled, class.
A negative.
A can't equal negative 4, and there would be our answer. Questions on fractiony stuff? Question on fractiony stuff. We did a lot with equations this year, but we also worked with things that were kind of like equations, but instead of equaling something, they were more than something, smaller than something, maybe the same as something or smaller, right? We call these things inequalities. We have 4 inequalities, 5 inequality symbols. We have this one, which is
Greater than.
Less than. Greater than or equal to. Less than or equal to.
cannot equal or does not equal. We had all these different things. We said we solve an inequality using one of these the same way we'd solve an equation, unless we do what? It's exactly like an equation, unless.
A negative.
What about a negative?
Divide by.
If you
negative?
divide by negative, technically if you multiply by negative, that just doesn't happen very often. But if you multiply divide by negative, we flip the inequality. Write this down. 7x positive 3 is less than or equal to 24. 7x plus 3 is less than or equal to 24. If this were an equal sign, I would get the x by itself, class. I would subtract the 3 or move it over as a negative 3 to get
7x equals 21.
or less than or equal to 21. And then we divide away the 7 to get x is less than or equal to 3. I never divided by a negative. I was dividing by a positive 7 here. So I don't need to flip the inequality around. But if I had something like this, write this down, 2x plus 4 minus 5x is greater than 15. Well, here, my first step, class, is to combine the,
Negative 5x and
yeah, combine the like terms, combine the x's to get.
Negative 3x plus 4.
And at the same time, let's ditch the 4 as a
Negative.
negative 4. Am I dividing by a negative 4?
No.
I'm just moving it, so I don't flip the inequality. I leave it a greater than, and I get,
11.
now to get x by itself, what do I have to do, class? Divide by
Negative 3.
negative 3. So now, as we cancel the negatives and the 3's to get x, I've got to
Flip the sign.
flip. So instead of a greater than,
Less than.
less than, and we'll rewrite our fraction as
Negative 11.
negative 11/3. Just slide the negative out to the front. Questions on that problem? Write this one down. Negative 5 is less than or equal to 4x plus 3 is less than 11. What kind of inequality is this?
Compound.
Compound inequality, very good. And for a compound inequality, again, we still just kind of solve it like an equation. I'm trying to get the x by itself, class. So first we're going to subtract 3 from everything, right? So in all the spots, what do I have now, Adam?
You have negative 8 is less than or equal to 4x is less than or is less than 8.
There we go. And now to finish solving here, Dylan,
Divide by everything by 4.
to get,
Negative 2 is less than or equal to x is less than 2.
all right, now how would I graph this inequality on the number line, Lana?
On the negative 2, you put a close dot, and then on the 2, you put a open dot, and then you shade everything in between.
And there we go. Questions on inequalities. We remember this from earlier in the semester.
So if you, like, the top thing's a negative, but you divide by a regular number, you don't swap the signs. Like negative 8 divided by 4.
Right, because I didn't divide by a negative. I divided a negative, but I didn't divide by a negative, so we don't flip anything. Good question. Good. We also talked about graphing linear equations. Remember a linear equation? What does it look like when you graph it? Straight line. That's hence the name linear, right? And so when we graphed, remember, we had these two number lines called axes. The horizontal was called the x-axis, the vertical called the y-axis. They intersected at a point called the origin and formed four sections called quadrants, right? And when we graphed our linear equations, we always try to get them into a certain form. What was that form called?
Slope-intercept form.
Slope-intercept form. What is slope-intercept form of an equation, class?
Y equals mx plus b.
Y equals mx plus b is the form we're going for. And the key to slope-intercept form then is get the y by itself. So if I had 2x minus y equals 7, if I want slope-intercept form, I've got to do what? Lana?
Divide the 2.
No, I want to get y by itself, Lana.
Move the 2 over as a negative.
The 2?
The negative y? The y?
Double switch the.
I could. Let's take it a more conventional approach. Move the 2x. We don't have a 2, Lana. We have a 2x.
Oh.
You said move the 2. Move the whole 2x over as a...
Negative.
And what was that? What would that give me?
Negative y equals negative 2x plus 7.
Good. Put the 2x, the negative 2x, in front of the 7, so we have the y, then the equals, the x term, then the constant. But it's not a y, it's a negative y. What should I do now?
Divide by the negative.
Or, much easier idea would just be, change all the signs.
Oh, yeah.
We're done. We've got slope-intercept form. What do we graph first, class? The slope or the intercept?
Intercept.
And what kind of intercept? X or y?
Y.
It is a y-intercept. So negative 7 on the y-axis is where we'll start. From there, we'll track the slope. Slope's 1 over what?
Rise over run.
Rise over run. So here, I don't see a fraction.
Put it over 1.
So I'm going to rise, class,
2.
2, and I'm going to run
1.
forward 1. And we're going to simply connect those dots with a straight line. Suppose I had this, a 3x plus a 5y equals 10. Well, if 3x plus 5y equals 10, what do I need to do? Stay with me for just a moment to get slope-intercept form, class.
Switch
Change
to
the 3x
3x.
over
As a?
negative.
So we get 5y equals,
Negative 3x plus 10.
and then
You divide the 5.
everything by 5. That's going to give me?
Y equals negative 3x over 5 plus 2.
3/5 x.
Negative 3/5 x plus 2, negative 3x over 5 plus 2. It's the same thing. I'm going to start by plotting the,
2.
as my
Y.
y-intercept. So I'm going to go to positive 2, and from there, class, we're going to,
Right, or go down
no,
there.
you're right,
Go up 3.
rise.
Five.
Use the terms rise and run. I'm going to rise 3 and then run
Backward 5.
backward 5. So 1, 2, 3, 4, 5, something like this. And we'll connect the dots. I'm going to line like that. All right, we'll finish our review in the next lesson, followed by the exam. No homework.
I have a time.
All right. Have a wonderful rest of your day.